Great. As I was introduced, my name is Bruce with Team Nona. We're doing desalination via a different approach in a way that makes it decentralized, reliable, and easy. Our team has two members right now, myself. I joined the team from a product development team at Rivian. Finance and strategy is my background. My partner, Jung-Hyo Yoon, who will be in the breakout group, is a research scientist at MIT. Who has 20 plus publications and invented the technology which we are seeking to commercialize. The problem that we're addressing very broadly is water scarcity. This is exacerbated by climate change and growing populations, and it's a problem everywhere, including the developed world. Some estimates say that by 2071, half of US aquifers will be depleted at current usage rates. And this is ironic because there's so much salt water around, underground and on the surface. But technologies for desalination today only work really well at one scale, and that's huge. They tend to be centralized in wealthy municipalities, which leaves many people and many applications unserved by desalination. So here's a brief overview of existing desalination technologies and what we're doing differently. We're familiar with distillation, thermal distillation. Reverse osmosis is how 70% of desalination is done today. That you can see in the middle. It's basically a filtration process is the easiest way to think about it. Very efficient at the large scale, but has a set of maintenance issues because it requires really high pressures and it's essentially a filtration process. And that has maintenance inherent in it. What we're doing is called ion concentration polarization. This was developed here at MIT. Essentially, we're passing water through a channel and using electrical attraction to pull salt and bacteria from the water stream. So we eliminate ever passing water through a membrane or a filter. We're operating at really low pressure and really low temperature. So we're solving a lot of the issues that kind of bind desalination to these large centralized facilities now. The result is that we can work in a lot of places. So at the portable side of things, we can be smaller and lighter than anything on the market today because we're ditching filters and also the high pressure plumbing and pumps. And that's treating seawater. Treating brackish water, brackish groundwater, of which there is a lot, we believe we can be more efficient than any technology that's out there today in terms of electricity usage. So that opens up huge opportunities anywhere where brackish water may be required to water crops, feed livestock, or where oil producers produce a lot of water that is brackish. And all these applications may be far from the wealthy municipality, far from the big plant, and we can offer a good solution there. Our traction, we have working prototypes that have been tested in the real world. We have 3 patents. We have 600 customers signed up to pre-order our device, the portable one, which we'll launch with. We plan to launch with that portable device in 2024 and hopefully have some large-scale pilots for those larger industrial uses I mentioned by that time as well. What we're looking for today is partnership. I'll list three categories of need. Number one is manufacturing and development for our portable devices. We're at the point now where we're working out manufacturing and distribution, and we could use support there. Distribution, partners, and disaster relief. We know a lot of your organizations do great work in this area, and given the low maintenance and low size and weight of our devices, we think there's big potential there. And third, development partners for agriculture and fracking use case. So this is a big area of potential where we need customer connections or connections with folks in industry to work out the real potential of our technology here and work on solutions. So if you're an oil producer, a company that does irrigation engineering or any kind of water treatment, I know I saw Veolia on the list, among others, we'd love to talk to you about how we can have a potential fit. With that, thank you very much and open it up for questions.
Great, thanks, Bruce. So first question, does this work to filter particles and other impurities besides NaCl?
Yes, it does. So we can pull out NaCl, so salts and also bacteria from water.
Great. And also, why are you starting with these portable units versus doing it at a greater scale at this stage?
Yeah, that's a great question. A grant that we're on right now from the U.S. Army has kind of dictated a portable size, portable form factor that can support a squad of 10 soldiers. And so our prototypes are nearly there. We're very close to having a product. So it's a speed to market idea, even though we're very excited about the prospects of those larger applications I mentioned.
And final question, what is the scaling factor limitation? How does it, what's the throughput scale?
Yeah, so currently, when we talk about a portable device, the prototype we're building now is what we'll do 10 liters per hour. So 2.5 gallons per hour for the Imperial folks. And that's the portable form factor that we think is really good for the military. We think is really good for recreational sailors and disaster relief applications. But there's no limit to how high we can scale it up. There are comparable systems with similar, though older technologies that have been built to do 30 million gallons per day. So we can scale up as large as necessary.